This is issue number 65 for the Kaiju Engine, where we are going to be making the rendering code a little bit more streamlined because right now it's a little bit of a process where you have to know a little bit about the rendering to make it operate. And one of the things about the Kaiju Engine is even without an editor, a visual editor where it's got nice fancy drop downs and buttons and all this other junk, um, you should be able to write a game in pure code without even having to use the editor. And that's just because I like writing code and that's something I want to do. So the code should be not purely based around this whole editor is generating this content for you, but instead it's designed so that you can use it in code in an easier way. And then the editor is built on top of that to build for that and that sort of stuff. So this is not an editor first engine, which I believe most engines kind of are. This is more of a code first engine with an editor being built on top of it later. So we'll create this concept. Now, also, I'm not going to say that this is going to be the ultimate end solution. This is just what we're going to work with now. I like to work with something solid enough to play around with, and if it becomes too cumbersome, just refactor. Refactor is a part of the entire process of any good software. It shouldn't be something that you're afraid of. It should be just something that you constantly you constantly are doing. I'm going to create something called drawing.go. And this is kind of just going to consolidate some of our drawing code. Rendering. And we're going to say type drawings. Did I spell that? Drawings. Struct draws is going to be a list of shader draws. Or a slice of shader draws. Sorry, I programmed in so many languages I wind up using language from all of them. It's a vector. Uh, Slice. Draw map. And this is just going to be a quick way to look up these drawings here by shader as they are grouped by that. So this pointer is going to point to an item in this slice. Of course, that's a dangerous thing to do because this slice um, could remove things from it. So we need to be very careful about operating within that. In fact, to start, since let's not even worry about performance of looking up stuff. It doesn't even matter if we have 10,000 shaders, um, which sometimes happens. Sometimes people want one big Uber shader. Sometimes people want 10,000 shaders. Let's worry about performance when it's a problem. So we're actually just going to do this for now, and then we can do other lookups later. But since we are not using the mapping, we need a way of looking up that a particular drawing. So we'll write that function just after this. So we're going to return drawings, and we want to set up that guy. Let's do funcd drawings find shader draw, and this is going to be by shader. So that looks about right. What are you mad about? Hold on, let's go through the draws. If the shader draws I dot lowercase shader is equal to shader, return the address of that. Okay, so cool. You probably want to. I don't like having nil as or null, whatever you want to call it, as a form of error checking. I would rather have something explicit, and for now we'll just do error new, shader not found. That way we explicitly we don't do is equal to nil. I don't know. That always bothers me. Seems a little lazy. Even though I do it, and I think I've done it here. Yeah, principles in the moment. So we're going to want funcd drawing or pointer drawings renderer and we're going to pass in d.draws. So that's going to be our render function that we call, which goes through and renders all the things. And of course we need to add a drawing. Add drawing. And we're going to want the shader. We're going to want the draw group draw instance group. This is a grouping that you create. And for the most part, it's probably just going to be one that's in there. So draw, okay, is equal to d.draw, or let's say find shader, and it's not going to be okay, it's going to be err. If the error is not nil, that means it's not in there, and then we can set draw. I don't know what it's doing here. Let's set, we'll say new draw is equal to new shader draw shader d.draws is equal to append d.draws new draw is equal to regular equal to the last element in the slice d dot that's if we have a draw map. We don't have a draw map. If dg okay and d dot, we're going to have a function for finding the group that this belongs to. If you remember, I'll show you in a second. Draw group, okay, dg.merge draw group, and let's say draw.instance groups equals append instance group draw group. Okay, so if you remember our draw group, let's actually go to draw group. We have a mesh and then we have textures. So whenever we do an instance drawing, we bind a mesh, so VAO with a bunch of vertices and indices and data about the vertex normals and weights and for GPU skinning and all that other stuff. So we have all this information about the mesh, but we also have textures. We bind the set of textures and then we draw a bunch of instances with unique instance data. So we can have two draw groups with the same mesh but different textures, for example, because the textures are bound separately, are bound, and then all the instances are drawn. So when we look up a group, we want to match the mesh, and then we want to match all the textures. And they don't have to be in the same order because we're actually going to be winding up changing this out a little bit later because we need to bind to a certain thing on OpenGL, like a string or whatever. So we do want to unsorted match all of the ones in there. So that's what this match group is going to need to do. And then the merge function is just going to take the group that's being passed in and merge it into this existing group because a match was found. So let's start off with our func d drawings match group. Oops. Shader draw dg draw instance group. And this is going to return a draw instance group and a bool. This doesn't know what we're doing yet, so I don't blame the AI on that one. So var dig is a draw instance group. I like to say nil there just so I know what the heck's going on. For I is equal to 0, I is less than the length of sd.instance groups. And dig is equal to nil, and we haven't found it basically. G is equal to the address of that guy if g.mesh is equal to dg.mesh. I'm going to have a new function here, textures match. And we're going to say g textures and dg textures. Then dig is equal to g, and we return dig, and dig is not equal to null. Again, I don't like to call function and use null as checking for something. I'd rather pass back a boolean there, for example. I guess I should technically pass a boolean here because it's true, false. That's basically what's going on here. I don't really need to know there is an error because if there is an error, then yeah, we just make it anyways. Okay. So we need this function now. So this is just a free floating function, textures match, and this is going to be A, texture B texture. Let's see, if the lengths are not the same, return false. That's correct. Then we're going to go through and nope, this is doing an order check. I don't care about the order. So we're going to say for blank and TA range A, if not slices dot contains what on earth BA return false. Cool. I added slices up there. Okay. So now we have our match group. The textures in any order need to all match. The meshes have to match. And now we need our merge function. So let's go to, let's see, DG match group, instance group. We want to go, yeah, draw instance. And we will put it here. Func D draw, yep, merge. This is going to be the instances, append the other instances, yep, increase the size, yep, add to the data, and regenerate the texture. Okay, I guessed that correct. Now we're going to make it a little bit easier to do some more adding of this stuff. So we're going to go to our shader draw, and we're going to add in, before we add in anything here, let's actually go to the main and let's refactor this just a little bit. Func test drawing, and we'll just take this block of code here, and we're just gonna cut it and plop it up here. Means we need to have the host. This is taking forever to save. So let's do, we have add instance. So instead of creating shader draw and that sort of stuff, we can say host dot drawings, which we don't have yet, add drawing, and we're going to add the shader and the draw group, which we've set up, and we don't need this anymore. However, I'm going to return the address of T, which is this guy here, triangle shader data, just so that I can continue my little test of moving it to the side. T is test drawing host. So now we need to add this drawings to the host. So, oops. So let's go to host and let's add in drawings, rendering.drawings. Then we need to add in, just add it at the bottom here, drawings, rendering new drawings. Then we want to create a helper function, func host render, which is going to do host.renderer.readyFrame, and we're going to pass in, actually, let's just cut this from the main. Let's see, host readyFrame, draw and swap buffers. We'll cut all three of those. Come paste them over here. And this is just going to be host drawings renderer, and then swap buffers. And then we can say host.render. Okay, let's see how that goes. Okay, we got an error, dereference. Instance groups is likely not set up when we set this. Oh, SD is nil. SD is the shader draw, which is this draw. Find shader draw. If not okay. Silly. That's because I had error is not equal to nil and forgot to put to flip that. There we go. So we still have our drawings and it's still working out. Cool. So that simplifies it just a little bit and moves some of the code that I want out. We still have to construct our object, our textures and our instances and all that sort of stuff in our instance data. But now we can just say add this group of drawings because they are all instances of each other. Add this group of drawings, given the shader to our drawing list, and then just go draw them whenever host renders or whenever render is called for the host. So that's the little bit of cleanup that we'll do for now, and we'll obviously, like I said, do more refactoring and more cleaning up as we go. Um, cool. I think that's it for now.